And we're back. Okay, so Ozan, I hope that you're more clear. So what I was saying earlier about we can have all kinds of variables inside of ints, integers, strings, doubles, whatever, inside of a method, right? And we can pass multiple variables to a method. So for example, in the max method, we passed 2 integers to the method, right? But the method can only communicate one thing back to us, okay? It's either going to communicate nothing, like a void, or it can communicate one thing back, one value. So like in the max method, it can only give us one value back. Later, we'll talk about when we get into like arrays, and next semester when you talk about objects, those things can represent multiple values in a sense, but for now, even that's one thing. Like you can either return one array or one object, but you cannot return more than one thing. So again, I'm having a hard time coming up with a real world example, but just the idea is you can put multiple things in. You don't have to. You can have a method that doesn't take any parameters. It doesn't take any arguments, okay? But it can only return at most one thing. Okay, it can only send one thing back. So I hope that clears that up a little bit. Okay, but inside of that method, inside of main, inside of any method that we write, we can put as many new variables as we want. They'll only exist inside of the method. They won't exist outside of the method. So yeah, okay, so I think hopefully that clears things up for you guys. Let me see, was there anything else? Just want to make sure that, because with the power still being out here, I'm not able to charge my computer. So if it dies in the middle of this class, then that'll be it. Okay. I do want to go ahead and talk a little bit about the passing, sorry, the void method example. So of how to, so if I share this. There we go. Okay. So this slide we're talking about where the void, where it doesn't return anything, or the test return grade. So let's just go ahead. I think that, yeah, I mean, I think that we are at a place where I can hold off on too much new material. We did the break and the continue in the loop. We also have introduced quite a bit on methods for today. So I just want to go ahead and do some examples then, so you guys can see. All right, let me share my JGrasp. There you are. All right. Let's make it a little bit bigger so that you guys can see it better, hopefully. Okay, this is chapter 6. Let me go back because I do want to show you the break and continue stuff here. Okay, so as we did this on the slides, but I want to also show you this in real life. Okay, so here we're going to test the break. Let's continue. Okay, so the break, if we were to put a stop point here. Okay. So if we look at what sum and number are, we can check and see, okay, number is less than 20. Yes, it is. So we should go inside of the loop. We'll add 1 to number. Number becomes 1. We will take sum and add whatever number is to it. Right, so 1 plus 0 equals 1, so we'll assign that to sum. Sum is not greater than 100. is not greater than or equal to 100. So we don't go inside of this if statement. All right. So now we add 1 to number. 2 plus 1 equals 3. Yep. So still not greater than 100. Okay. Number still not greater than or equal to 20. So number is less than 20. So that's true. So we'll go inside of it. And we'll keep doing that basically until one of these two conditions is met, right? Until let's get closer and closer to both of them. We're getting closer. Number becomes 13. Sum becomes 91. You know what? I did the math wrong in this earlier. This is why computers are better at counting and doing math stuff than me, all right, than human beings, right? Okay, let's go one more. So number is going to become 14. Sum, when we do 91 plus 14, we'll get 105. All right? So now this condition is now true. So when this if statement gets executed, this will get seen, this line inside of it will happen, break, which will break out of this while loop. Okay, the thing to remember here, break, okay, break is going to break you out of the innermost control structure that it can be associated with. So if you have a loop inside of a loop, it will only break you out of the inner loop. If you have a break inside of a switch case statement, it will only break you out of the switch case. It won't break you out of the loop. Okay, so that's important to remember. So now notice sum is 105, number is 14, number is 14. So even though this condition is still true, number is still less than 20. So even though that condition is still true, we're out of the loop because we executed a break statement. Okay. All right, and the sum is 105, as we would see here. Okay, so let's make one minor modification. Okay. And we'll see how this will drastically change. So anything, what was number at the final? What was number's final value when we saw it here? What was it? I can't remember. Did you guys notice? Not sum. What was number's final value? Let's see. Some of you guys are answering good. You guys got good. Right, 14. Right. So the number got to be 14 inside of here. So anything 14 or greater over here is going to operate the same way. If I compile this with 14 and run it, right, it'll still be 14 and 105. If I make this 15 and run it, right, it'll still be 14 and 105. Anything 14 or greater, this thing will operate the exact same way. Okay? But if I go lower than 14, okay, and I run it with this thing lower than 14, now the thing that ends my loop will be this condition instead. Notice here, number is now 10 when it ends, the sum is 55. Okay. If I make it 13, number is now 13 and the sum is 91, right? Because when this condition was false, it exited the loop. For any value 14 or greater, the original value was 20. For any value 14 or greater, this becomes the condition that breaks the loop, that gets me out of the loop. Okay, so for us, when we are trying to figure out how the loop is going to execute, the best thing to do is like what I did during the class here, where I showed the table and I had the values, one by one showing them. What I might be able to do today, let me do that right now, actually. Actually, I'm going to pull up the whiteboard app, and while that is coming up, I'm going to switch over to the continue one. Okay. All right. So continue, let's look at what happens with this one. Okay, and then I'll go back to the whiteboard and I'll show you what I'm talking about. Okay, again, sum and number are both 0. We'll add 1 to number. Okay, we'll check a condition. If number's not 10 or 11, this doesn't really matter, right? We don't do anything. Okay, we just move on. Sum plus equals number. So it's the same thing as before, where we keep going through, we add up 15, 21, 36. Okay, so now we're about to hit a situation where this is going to become important. We add 1 to number, we get 10. Now, if number equals 10 or number equals 11, which it does, it is equal to 10, it's going to execute this continue statement, which means we're going to skip all remaining lines in the loop, and we're going to go back and check this condition again. Okay, so notice we didn't change anything about sum. Number is now 11. We're going to continue. Don't change anything about sum. Number is now 12. It's no longer one of these, so we will hop over that if statement and execute the next line. So now it'll be 57. Okay? Same thing, keep it going. Right? And we'll keep going. Okay? The sum is 189, and that's it. And the number, of course, was 20 because there is no break based on some earlier exceeded value. Okay. Let's see. All right. So what I'm going to do is You have a question over here? Oh, no, y'all are still answering the 14 thing. Yeah. Okay. Let me show you what I would show you on a whiteboard situation. So look back at this, look at the test break. Number starts out as 0, goes up to possibly 20. Sum starts out as 0, goes up to 100 to break, okay? So when we want to track a value, okay? So I'm going to share this whiteboard if it's an option, which it is not giving me. I know why. I know why it's doing that. Okay, I'll make up a recording of this at another time and post it because basically what I want to show you is, actually what I can do is I can come back to here. Okay. Is here where we have this kind of table idea where you take a value, take a variable, and you say, what is its initial value? And as it changes, so when number adds 1, we change the value of number, right? Ideally, what you would want to do is you would want to say, okay, draw a line through its old value and give it a new value. Then when it changes again, draw a line through its old value, give it a new value. Okay. I would show you this on a whiteboard if we were face to face right now, because I think that would be more helpful. Because especially when you're doing this, because I can guarantee you, quizzes, the midterm exam coming up in a couple weeks. In both of those, you're going to have a question like this, where I'm going to ask you, what is the final value of number? What is the final value of sum? It won't be this question. It won't be this exact question, but it will be something like where I give you an initial value. I'll give you some code involving a loop or a method call or something like that. And I'm going to ask you to tell me what is the final value. Okay. And the best way to do that is to not just think about it, not just try to look through it, but to actually step through. Okay, number is 0, sum is 0. Okay, number gets added and changed to 1. Sum gets changed to 0 plus 1, which is also 1. Okay, we go back. Number gets changed to 2. Okay, then sum, all right, gets changed to 2 plus 1, which is 3, gets changed its value, and so forth. And we keep, draw a line through this one and say, okay, now it becomes 3. Then 3 plus 3 equals 6, so sum gets changed to 6, and so forth. And we keep going over and over again. Like I said, I want to show this to you on the whiteboard. I may have to save that for next week at this point, because yeah, Microsoft Teams does not allow you to share something from a screen unless it was available at the very beginning of the call. So I have to, any program I open right now, I can't share that screen with you, unfortunately. So I can't share with you the whiteboard even though I've opened it. Okay. So instead what we'll do is go back to the JGrasp. Was there a question? Did number less than 13 add 13 to sum? Let's take a look at that. Good question, Oslam. I like that. Let's take a look at that one. So you're saying when we have it like this, why did it add 13 to sum? Okay, well, look, we have it perfect here. We'll have this breakpoint. Let's take a look, because I didn't step through this one. Okay, so number is 1. 1 plus 0 is 1. Sum is not greater than 100. Okay. Number is 2. We add 2 to sum. Number is 3. So she's asking, let's get all the way up to, okay. Number is 11. We add 11 to sum. Number is 12. We add 12 plus 66 is 78. Yes. Okay, sum is not too great yet. Okay, so now this is where I think your question comes in. Now, 12 is less than 13. Yes. Okay, so now we add 1 to number. 12 plus 1 is 13. Now we add 13 to 78. We get 91. This is still not true, so we don't break. And now 13 is less than 13 is false, so we get out of the loop. Okay, so the answer to your question, I guess the short answer to your question is, in this particular situation, because number was changed before the sum was added, so even though this, when we added 1 to number and got it to be 13, even though that then at that point would have made this false, we don't check that again until we get back to that point. Okay, so this is 13, it adds, then we check. Had we done this like this instead, where the, let me get out of here. Okay. Where had we changed the value of number after changing the value of sum, then it would be different. 13 would not be added in that case. In fact, if we run this now, what you'll see is now 13 did not get added to sum because the changing of the value of number came after the adding to sum. Okay, I hope that clears that up. All right, so that's the break and continue stuff. Let's go back to this, because I do want to go ahead and cover methods. I want to make sure we talk through the methods. So I want to look through specifically the test max method. Let's see, because that was the one we talked about a lot. So I want to make sure we go through that one quite a bit. And then I believe the void method, right? Test void and test return void. Okay, so let's talk about the test max method first, okay? So again, we have public, static. Just get into the habit of writing those. We'll explain that next year about why that's so important. Return type, name, again, this name, the compiler does not care. We could call this maximum of 2 integers method, right? We could call it anything, as long as whatever we call it here is the same thing as we call it here, okay? But as I'm sure you would agree with me, that's a lot of typing, and I do not want to have to type that much every time I want to call this method, okay? So the best way, just go ahead and call it something simple, short, that you understand what it means, okay? It takes 2 parameters, has to be an integer parameter followed by another integer parameter. Okay, we pass these 2 values. The value of I, in this case, the value of I is going to get copied into the value of num1. The value of j is going to get copied into num2. Okay. So let's take a look at how this works. Okay. So I is going to be declared and given a value of 5. J is going to be declared and given a value of 2. Now, this is where this step stuff starts to get a little interesting, because this right here, this a straight down arrow is a step over. What that means is just take this and treat it as a single line of code and just go over it. So if I do that, I don't go inside of the max method. Now the code did, when it executed, it went into the max method and executed all that. But I'm saying I don't want to see that. I assume that everything goes fine in there. I don't want to see what goes on inside of there. Okay. So then it just goes ahead and gives me my results. Okay. But because this lesson, we're really interested in what goes on inside of these methods, we're going to use this arrow. This means the step in method. Okay. So we're going to step in to the method call. Now, if in one line of code, if there were 2 method calls, like say we did plus max, like that, okay? All right, if we were to do that, then it would step into this one first, this one second, okay? These get executed in order, okay? So, but I don't want to do that. What I want to do is just want to do it like it's normal here. Step in, so I'm going to step into the max method. Now remember, I was 5, j was 2. I came first, j came second. Num1 gets the I value, 5. Num2 gets the j value, 2. Okay. I have this result variable. Because it has not been given a value, it doesn't show up. Okay. Now notice 2 things here. Over here in this, there's arguments. This is this stuff, right? This is the variables that are declared in this parameter list. Then we're going to see this locals variable. Now when I step, okay, when I get my result here, notice now result is a local variable. Result is something that exists that I declared inside of the method. I use it inside of the method. Arguments are these things that were declared as part of the method's signature. So they exist only inside of the method too, but they're part of this method signature. They're not declared in this local area here. Okay, so they're slightly different. Okay, all right. So then result is 5. I return it. The maximum between I and j is k. Right. Notice k got that value of 5 here. Okay. All right. And I can change the value of I and j. What if I said j is 20? Let's take a look. So 5, 20. I'm going to step in. Okay. Now, num1 is 5, num2 is 20. So the result is going to be what num2 is. Now here's another, let me tell you about this one. This step out, suppose we get to a point inside of the method where there's another lot of lines of code, like 20 lines of code less to execute. but we've already seen what we wanted to see inside of the method. We didn't want to continue on inside of the method. We just want to hurry up. We don't want to step through ... for the next 20 lines of code. We want to just get out and go back to the calling method, right? We can do that by this step out. So step in gets me into the method. Step out gets me back out of the method. Okay. So now K is going to be assigned that value of 20. And we will display that. And we will be on our way. Okay. Order matters. So if we were to say, just because I comes earlier in the alphabet than J and num1 comes earlier than num2 does not mean that that's how it assigns those values. Okay. So if I did J and I, for example, so now J is the first parameter, I is the second parameter. So when I have I is 5 and J is 20, now J's value 20 will be copied into num1. So num1 should be 20. I's value will be copied into num2. So num2's value should be 5. Let's see if that's what happens. Yep. Num1 got J's value because it's first. Num2 got I's value because it's second. Okay. Fortunately for us, in the max method like this, order, which one comes first, which one comes second, not so important, right? Because it should give us the same result either way, right? Okay. One more thing we can do is we don't have to pass variables. We can pass a combination. We could do, what's the max between I and 10? Let's debug this one. Okay. So now notice I is 5, J is 20, but we're going to check what the I max between I and 10 is. So when we go in here, num1 gets I's value, num2 gets this static value that we passed. Okay, so J, this value of 20, not seen inside of this method at all. Okay, it's not used at all. All right. So the maximum between I and 10 is 10. Okay. All different ways that we can do that. Let me go ahead and return this back to what it was before. You guys can play around with it. I encourage you, these, no, not 2J. These code segments, these Java codes, are available on that shared classroom materials folder. I encourage you to download them and take a look and just see, play around with it, so you can find it and understand on these simple examples how you can do these things. Okay, all right, let's finish up with these last two because I'm getting a little bit low on battery. So let's finish up. Okay. Now we can have a void method. So void, a lot of times we use void methods to display things. Okay, because void doesn't return anything, since it doesn't return anything, it really, for the most part, is useful for displaying purposes. Now, that is not to say in any way that that's the only thing it does. As we'll learn at the end, towards the end of this semester, another good void method is to write things to a file, okay, or read things from a file. Right? But a void method doesn't return anything, so it can, generally speaking, be used for displaying purposes. Okay? The reason why I want to make sure this is clear is probably, I would say, when it comes to methods, the biggest confusion that a lot of new programmers, a lot of early programmers have is the method supposed to display something or is it supposed to return something? And those are two different things. Okay, notice here in test max, okay, the max method is intended to do what? Is intended to determine the maximum between two values. Notice it doesn't display anything. The max method itself does not display anything. It only returns a value. It returns the maximum of the two. Here, all right, is where we display what the max. We don't have to display the maximum. We don't have to display it. We might use it as some other part of some other thing we're doing. All right. But if a requirement for a method, like in a program, like for example, your assignment 2 that is out there, right? If the method says return this value, then it needs to return something. If the method says display this value, then it needs to display that, okay? Two very different things. Make sure you get to know the difference between what does it mean to return a value, what does it mean to display a value, okay? I'm being super pushy and emphatic about this because I would say when we start doing quizzes and exams and assignments about methods, and the question is about a method, that is the biggest confusion we see. Is we say return this value and students write system.out.println. So no. If it's asking for a return value, I need to return something. If it's asking to display something, I need to system.out.println. Okay. So here, this example, the grade is, and then we print the grade for a certain value. So notice this set of if else, this should be pretty straightforward, pretty standard. Okay. The void says I'm not going to do return anything. I'm going to take this value, and based on it, I'm going to display A, B, C, D, or F. Okay. Again, this is an American-based system, so this isn't based on an American university system. So this is not related to your assignment. Okay, make sure you understand how to do this for your assignment. Okay. So we send it a score. We print whatever their score based on the value that's passed. So here, oh, no. This is going to give me a problem. No, maybe not. Okay. Oh, okay. It hasn't worked before where I had this uncommented. Oh, well. Okay. All right. So here we're inside of the method, right? We're inside of this 78.5. Is it greater than or equal to 90? Nope. Is it greater than or equal to 80? No. Is it greater than or equal to 70? Yes. So we should get into that. We will print the letter C, and we're done. Notice here else. Notice here something else I want you to see. In a void method here, there's no return. We don't have to return explicitly write return in a void method. In a void method, when the method comes to the end, it just returns on its own. Okay. All right. So what about for this grade? What about 59.5? We pass it in. Notice score before it was 78.5. Now when we hear this arguments thing, right, now score has a different value. Why? Because we're calling the method a second time, a different time with a different value. This value gets copied into score. Okay. All right. So it's not greater than 70. It's not greater than 60. It is something else. So 59.5, which hopefully none of you get in my class, but it would be that F, right? So if we look at what the output was, grade is C, grade is F. Okay. All right. And the reason why these are put together on the slide, this test void method, test return grade method, is because this is going to result in the same output, but it's two different ways of doing it. Okay. So here, notice that if I were to compile this and Windows. Okay. Notice that it is the same output, isn't it? Grade is C, grade is F, grade is C, grade is F. The exact same output. But this is two different ways of doing it. So remember what I said earlier. We have a problem, multiple solutions are presented. Both of them are correct. Right? There's not one right answer to the question. This is a problem, multiple solutions. Okay. So here, what we do is we system print the grade is, and now instead of printing the grade, we're going to get the grade. We're going to get a character letter that represents whatever the grade letter would be for this value. Okay. So now, so over here for test void, notice that print grade was a void method that took a score, that took a double parameter of score. Here, get grade is going to take a double parameter of score, but instead of returning nothing, it's going to return a character. It's going to return a letter. Okay. Same idea, where if it's greater than 90, it's an A, 80 is a B, 70 is a C, 60 is a D, and anything else is an F. Same thing, right? So same as here, same thing here. But the difference is that instead of displaying it, we are returning it. So here we're returning A, returning B, returning C, returning D, returning F. So how it gets displayed is by being a part of the print statement in this method here. Okay. So even though these show the exact same output, even if I were to roll back through this output right here, it would be the exact same. So we showed that earlier, where this test return grade method gives me the exact same output as this, wherever it is, test void method, right? Same output for the same values, right? It is done slightly differently. Okay? This method can only be used to display a value. I cannot get this value. I cannot do something with it. Right? This method doesn't display anything. It gives me what their grade is based on their score. Okay. That's a big difference. I want to make sure you guys are clear on that. If the method request is give me the grade, don't display it to the screen, just give me the grade value, then you need a method that returns a value. If what you want is for them to display it, but you can't do anything with that value, then you can do it as this print method, right? If you want to display but you don't want them to give you the value, that's this over here. Okay. I hope that's clear. It can be a little bit confusing. One other thing I did want to go ahead and do is I wanted to show how we can call these methods from somewhere else. Okay, so let me see and remember what I called this before. I'm going to use naming convention. Okay, so what we can do, save this first. Okay, so what we can do is, let's say we wanted to use the max method for something else. So I wanted to actually get values from the user, right? Okay, and I think I need to import, right? I need to import. So I want to say enter number 1. And then I say 1 equals and then I can do that for number 2 too, right? Enter number 2. And then I can say the max of num1 and 2 is, and notice I don't have to store this into a variable, right? I could say the max of num1 and num2 is max dot max num1 num2. Let's see if this works. Let's see if I've done everything correctly here. Right. All right. So here now, instead of hard coding some values to put in there, I'm going to get my user to give them to me. Okay. So let's put my little debug here so we can run through it. Okay. So okay, enter number 1. Somebody give me a number. First answer gets to choose it. Okay. Oh, whoa, you guys came all at once. Okay. Alper and Hakan, you were the first 2 to respond, so your numbers will be at 6 and 5, okay? So 6. 5. Okay. Now, what happens when I go inside of this? So if I step in, I'm going to go inside of test max, inside of its max method. 6 and 5 should give me 6 for a result. Good. Yeah, so far it works good. All right, and now I'm going to display the results of that. The max of 6 and 5 is 6. Okay. Let me choose a couple of different ones. Let's see let's see the biggest number, the smallest number. Actually, I'm going to use 42 because my son has been lately reading Hitchhiker's Guide to the Galaxy, and I don't know if you know this or not, but I don't know if you've read that before, but 42 is the answer to the meaning of the life, the universe, and everything. So, all right, so let's give us the meaning of life. 42. Okay. And let's see, what was somebody else's number? Yo. Autostoptionen Galaxy Rebel, the Hitchhiker's Guide to the Galaxy. Okay. Yep. I believe you. I've never read it. My son is reading it. I am wanting to start reading it. All right. Let's see. Let's do a negative number. Let's do a negative number. Let's do -1. All right. So now if we step in, all right. So now we got 42 and -1. The result is 42 as we would expect. And now we would display the maximum of 42 and -1 is 42. Okay. All right. So you guys have seen that. Remember, max doesn't display anything. It takes some parameters, it returns a value. A void method doesn't return anything. Normally, now I'm not going to say always because this is not always the case, but normally a void method is used for displaying things or writing to a file. Okay, because a void method doesn't return anything. some other type of method, a return type, oftentimes we won't display anything inside of that method. We will do some type of calculation. So here we're calculating what is their grade based on a score value. So we're calculating their grade, and then we are returning a value because of it. Okay. All right. I hope that's clear for everyone. The differences between the how to call this method from somewhere else. Notice that I can do this also for this method as well. Okay. Get grade, for example, I can call this from somewhere else. So if I were to go to, say, this interactions thing, let's return grade method, get grade, okay, and I can give it a score. Let's say 89.5. Oh, I think it needs to be in chapter. There we go. Yeah, I got to put the package name in it. That's why. That's why it wasn't working before. Okay. All right. So I give it, this class name, method name, and give it a value. Now, one thing is, in this interactions thing, this is going to be what I enter, and this is going to display what it returns. Okay. If I were to do that with instead of test return test void, and what's the name of it? Print grade. Test void method, not test void grade method. Okay. Notice a little bit of a difference here. Okay. One, when I do this in the interactions, okay, the thing is what it's going to do is it's going to display as part of it anything that is displayed inside of the method, and it's also going to display whatever is returned. Notice the difference. White letter here is what would be displayed. What's the system.out.print or print line. Green is what value was returned. So if you notice up here on, I'm going to expand it out so you can see the big difference. In the get grade method, notice the B was green. And the reason why is because this method returned a value of B. Okay. This, on the other hand, displayed the value of B, but it returned nothing. Okay. So that's a way that you can notice the difference. This returns nothing, but displays a value. This displays nothing, returns a value. Okay. So make sure you know when a question about methods is asking for something, make sure you know, is it asking me to return a value? Is it asking me to display a value? Okay. All right. We are going to end here for today as far as the lecture is concerned, because here in a few minutes, you will get a notification that you have a quiz today. All right, so for those of you who are in the lecture, who are here attending live, you will have until 12:30. Based on last week, the last quiz that we gave, make sure you turn it in sooner. I gave you till 12:30 instead of 12:20 this week so that you can make sure to turn it in by 12:20. Some of you had issues with not clicking turn in, or you tried to turn it in at 12:20 and it didn't let you. It seems like basically once it hits 12:30 and 0 seconds, it will close down your ability to turn it in. Okay, so make sure you turn this quiz in early. It will start accepting responses at 11:30. Okay, I could say this, but if you're not watching this live, then you won't even hear this message until afterwards. But for those of you, as usual, for those of you who weren't attending this live, your quiz will be right after that. Will be 12:30 to 1:30. Okay. All right. So what I'm going to do is I'm going to here in a minute, I'm going to post a link to the form because again, last time I did this, Some of you, the notification didn't pop up for like 20 minutes for some of you before you were able to get it. So I'm going to post a link to the form at 11:30. It will start accepting responses. Okay, and for the later one at 12:30. All right. If there's no questions, are there any questions? Nope. Okay. I will post the link here in just a moment, and you guys can start working on it at 11:30 and no earlier. All right. Good luck. Not good luck. Good preparation. I don't believe in luck. Good preparation on the quiz, and hopefully you are raring to go. All right. See you guys next week.